Yeah, we all know this is a mutual business, and we are not doubting your LLMs. We are just saying we are not happy with the latency. And do you have any cheaper LLMs in general? And we are a big RAG customer, you know, you can give us some good discounted fees. Yeah. Well, no, we got lack of confidence exists in RAG implementation or chat with your data use cases. I think he got RAG phobia. Anyways, this video is all about a new retrieval method called FLAIR, or forward-looking active retrieval augmented generation, which decide to when and what to retrieve from your knowledge base based on the confidence of the sentences that the LLM has generated. For example, if your LLM is answering your question but is not confident on specific tokens, words, or sentences, then FLAIR will take care of them with retrieving some knowledge just for the parts that they are not confident to give you a more confident answer. That's pretty cool. Then let's go.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, let's get into FLAIR, or forward-looking active retrieval augmented generation. So this is actually their official published paper. You can go through that, but I'm here to mainly start with the flow of how FLAIR works and then quickly show you a demo in Python code how we can leverage that. So let's see what FLAIR is trying to accomplish. In your RAG application, let's say here I'm gonna ask generate a summary about Joe Biden, right? And I have some knowledge database and I can retrieve some relevant information about Joe Biden, whether it's from internet, from my local documentation, whatever, to answer that user question, right? So what FLAIR does, FLAIR can technically predict what's going to be the potential next sentence based on the context of the data. For example, most likely it's going to say Joe Biden born in this date and this is the numbers of presidency of the United States, right? And as you can see here, each generated token or word has a probability. For example, how confident our model is about this date. And for now, for this sentence, everything was pretty confident, so we got this response back. But following on the top of that, it says Joe Biden attended the University of Pennsylvania, and where he earned a law degree. Now, as you can see, these underlying tokens or words are the ones that the model is not confident. These have low probability tokens. Then FLAIR gonna ask our LLM that, hey, generate a question that the response will be University of Pennsylvania. So the question will be then, where did Joe Biden attend the university and what he earned, right? So that question then will go all the way to my knowledge base, again, web, your vector database, Azure AI Search, whatever you have, and get those specific knowledge back. And there you go, we corrected that because they were not absolutely correct answers, and this is the correct university, and this is the date, and this is the domain. Because we were not confident, we retrieved them back. So again, the next question, Joe Biden announces candidacy for this date and president election on this month and year, day and year. Again, we're not confident about this. Going back to the retrieval, we got the correct date. So technically, this is the idea of how FLAIR works. And interestingly, they were benchmarking their solutions against a couple of other retrieval methods, let's say the single retrieve approach. And it seems like over the data sets that they have benchmarked, this green line, the green bar, which shows FLAIR approach, seems to be more promising compared to others. So let's see how it works in action. Good news is LangChain already wrapped that solution, so you don't need to develop this solution from scratch. What I'm gonna do, of course, you need to have your OpenAI key. I removed that after running this notebook. And Serper API. What is Serper API? That's a wrapper around Google Search API. Our knowledge base here gonna be internet, so I grabbed the information that we have low confidence from internet, but it can be your knowledge base, again, your vector database, whatever, right? It doesn't matter. Now, these are the imports you need to have them from LangChain. So make sure you have LangChain pip install and pip install LangChain underscore OpenAI. And after importing all, here I'm defining how I'm retrieving the knowledge. This is the place that can connect it to your Azure AI search or vector database, however you're retrieving knowledge. This is, for me, is Google Search API using Serper. And I have that already created. And by the way, when you sign up Serper for free, it's gonna give you, I think, a couple of thousand free credits so that you can search by API. All right, so here, this is the part that Flare is already developed under LangChain, so you just need to simply import Flare chain, and you can have obviously all these well-known parameters that we all know what they are. And by the way, because Flare is iterative, it keep continuously ask questions about the parts that is not confident in the answer. You can have the max generation length also limited, because each time LLM is being asked to generate a question, goes to knowledge database, so there's a cost associated with that too. For example, here I ask, explain the great detail difference between LangChain and AutoGen. We know LangChain and AutoGen is an open source library developed by Microsoft for creating autonomous multi-agent applications. Now, when I ran this, let me go all the way to the top, and let me show you the initial answer here. Let me open that up. There you go. It says LangChain is a software development framework that is designed to help developers creating program language. I'm not happy with this answer, right? This is technically without the starting Flare in place. Or if I show you that, if I quickly ask this question directly from LLM, let's say GPT-4 as an example, this is gonna answer me something else, because there's no retrieval method here. It cannot confirm that, and there's no Flare here too, so the answer is quite wrong. But now with Flare, we got this, and as you can see, there are some entities and terms that they're not confident in the answer, and we need to regenerate some question to get the answers and confirm them. For example, both tools have their own unique features. We don't know what they are. So it generated a question that the answer gonna be this. Can you explain the purpose of functionality of LangChain framework in context of software development, and what are the key distinctions between? So it's gonna capture the unique features, right? So go all the way back, retrieve the information, generated some answer for me. And again, there are some specific entities that it's not confident. For example, data-driven applications. It's not sure if LangChain is a data-driven application, right? So it generated that, or through its host. We need to actually check what does that mean through its host. So this is something it's not comfortable or confident about the answer. So this is again another follow-up question from our knowledge base, which is Serper API or internet. This is how we grab the information. And going all the way down through this iterative process, this is the final answer, which is much better than the previous one. So it's telling me both of them are for sort of AI agent frameworks, and it's talking to me that LangChain is for designed to, okay, let me go, to make, to make prompt engineering more efficient. Well, that makes sense for me now, rather than saying LangChain is a language development framework, which is not that necessarily. So that's all. It was pretty quick. Just wanted to show you an overview of what is Flare and give you an idea. You don't need to necessarily import Flare from LangChain, but use the probability of confidence of the token generated in the answer to know what specifically you need to retrieve again to come up with a more confident answer. This is something that we might have ignored. We just grab the knowledge, give it to the LLM, wait for the response, but the final response is generated by LLM, and LLM has seen some of the retrieved knowledge that you're bringing to the context, and it's giving you the answer, but even maybe the given context is not enough, so LLM is giving you the answer, but not sure for a specific part, or it's hallucinating, or whatever. So use that token probability to see what you need to refetch from your knowledge database, maybe other chunk of data, because now we have a new query generated by LLM on backend, grab more context to the prompt, and then get the answer in a more confident manner. So that helps a lot to boost the accuracy of the answer or groundness of the answer that you have from your RAG implementation. I hope you liked the video and you found value out of it. If you enjoyed, I would be happy if you press on like button and make sure you write down in comments or questions. Thank you so much and take care until next video.
Life is all about a battle between concentration and distraction. With concentration, you will grow to power and inner peace. Don't let them getting you to slaughterhouse with distraction. Dream big, my friends, believe in yourself, and take action. Take care.